Hello everybody, this is Mr. Bowman. So today we're going to look at the CPCTC and HL components. So the HL is pretty similar to the ones we've already looked at. CPCTC, or corresponding parts of congruent triangles are congruent, is an exceedingly common acronym for these proofs, but it's actually used a little differently. It's after you prove the triangles are congruent. So let's get in and see what we get. All right, so this one's going to be a little different. We're going to set this up on our own. It's not going to be as much fill in here, so we'll get a little practice here. So your first couple ones, it's usually good to go ahead and set your givens in to get them out of the way. And Alex has a little shortcut. You can hit send to proof, and it'll type it in and put the given for you, so you can go ahead and get those done pretty quickly. All right, but let's see what we got going on here. We want to prove RS is congruent to RU. So what do we know? We know RTS is congruent to RTU, so I know this angle is congruent to this angle in here. And I know SRT, so SRT up here, and is congruent to URT. So these two are congruent, and these two are congruent. So this shape you're probably seeing a lot of now. So whenever you have these shared sides, we're going to probably use our reflexive property, so that's what we're going to go ahead and say here. So I'm going to prove that this triangle is congruent to this triangle. This is kind of my goal. Then I'll deal with this. So let's prove they're congruent first. So I can say that RT, and where's my, there we go. Make sure we put that line segment bit, is congruent. By the way, if your line's still going here, you need to either re-click or hit the right arrow to get out of that line before you put the congruent symbol in. Anyway, RT is congruent to RT by the reflexive property, and you're going to hit validate to make sure each step works. So it's not going to let you get all the way done. You're going to know exactly when you hit a step that has a problem. Okay, so and then you're going to hit check after it says proof completed or something like that. So right now I have my two givens, my reflexive property, which is enough to prove they are congruent. That's the ASA, so that's the side in between those two. So I can say that my triangle, let's see, it doesn't matter. No, not really. So STR is congruent to triangle. Make sure these match up. So STR would be UTR, its counterparts. And that is through the ASA congruence property. So now that I've proved them congruent, I have one step, and that's where that CPCTC, or corresponding parts of congruent triangles are congruent, comes in. So I'm going to go ahead and send this to my proof. Notice that there's no reason this time because we have to say that. So that's where you can use the CPCTC property. It says your proof is complete. Now you hit check and it gives you credit. So it's a little bit weird how they set these up. All right, so let's do another one quickly here. Okay, so once again, sending our givens. Okay, so I have my bow tie shape here, and once again I'm trying to prove this, so I need to prove the triangles are congruent to get any extra pieces. So I have ST is congruent to TU, so my two top sides are congruent. SRT, so down here, is congruent to UVT, so top side, little angle, and whenever we get these bow tie shapes, we're really looking for vertical angles. So I'm going to go ahead and say the opposite of those intersections. So angle STR is congruent to angle UTV. And those are vertical angles. So let's see, where's vertical angles property? Now I can talk about those triangles. So triangle STR is congruent to triangle, STR would be UTV, by the, well, we didn't talk about this yet. So what property is that? So we have a side, an angle, and an angle. So the side's not between them, so that would be AAS. Okay, so angle, side. But that does take a little bit of practice to be confident knowing which one's which between those two, because they're very similar. All right, so now I should have enough, and then it's going to be through CPCTC. So what that means is if I've proved these triangles are congruent, it means all the parts are congruent. Okay, so all 6 angles, all 6 sides match something. So since I know these are congruent, I can say RS is congruent to VU because they're corresponding parts. They're if you flipped this over, they would land in the same part, so they're corresponding. So since they are corresponding and the triangles are congruent, those have to be congruent as well. Okay. All right. So HL, by the way, it works exactly like the other 4 that we've looked at. The only difference is it has to be a right triangle, and if the hypotenuse and leg both match, then you can say it's congruent from there. So, but it's very similar to SSS, SAS, all of those ones. It's just only applies to right triangles, which is a little different, but that's all it is.